even as, we as planners, as we come together, the architects, the engineers, mechanical, electrical, biomedical, interior designers, all of them come together to provide an environment that is aseptic, but also aesthetic. Now, simple as it may sound, there's a lot of it that goes behind the scenes, that we need to, that we will focus on. We do have instances where clients sometimes come up and ask, if you could help with doing up an operating room. Now, it is important to understand here that, as much as we're talking about the nuances of planning and operating data, it is but a part of a larger department that has zones and interrelationships that are driven both by functions and standards. So therefore, operating rules must be approached in the context of the overall plan as a part of department. As much as we speak about the planning of OT, it has to be viewed in a larger perspective of it being a functional element of a larger department. So first things first, we need to understand the user requirements. So how do you go about planning a surgical suite? So the first thing that you need to typically ask, when you get into this process is, what is the number of surgeries that you anticipate? That is the caseloads. That having been established, if somebody tells me that, hey, I'm going to do, say, 20 surgeries in a day, it doesn't yet tell me the entire story, because then the next question that I would have is how many of them are minor, how many of them are major, what is the likelihood of, a surgery stretching to 5 to 6 hours or 8 hours, how many can be done maybe, in 20 minutes, 30 minutes. So the level of invasiveness, likelihood of infection, that also is an important determinant. So if you are doing very deep wound surgeries, likely that, it's going to be a major surgery, going to take longer. Type of sedation that you use to conduct the procedure is an equally important, element to identify early on. When we plan, it's also important to understand the number of staff expected in the room during the procedure. So if I am doing something like, typically the examples that we come up with are cardiac, neuro, ortho. We typically have more assistants, more equipment, and so these are considerations you take into account when you're planning. So that's the next point, equipment needed to support procedure. And another important consideration is whether the operation room is going to be dedicated to a particular discipline or is it likely to be shared. So if you look at the instance of, I'm sorry.
Carry on, sir. There was some disturbance from external person.
So if we look at the instance of teaching hospitals, we are expected to dedicate operating rooms to certain disciplines. For instance, you need to earmark certain numbers for general surgery, certain for orthopedics, certain for ophthalmology, certain for obs-gynae. So that's determined largely by the National Medical Commission, which says that you must earmark certain theatres for certain disciplines. In the private sector, you have the choice of using them as a common space for multiple surgeries. Then too, you can come up with these issues like an ortho surgeon saying that, hey, I need my own space. I'm not going to work in a theater which is going to be used by others because mine have supremely aseptic, requirements. So these are decisions and discussions that you get into early on to understand, how much of that real estate is something that can be shared, how much of it can be dedicated, and that has a bearing on the number of operating rooms that you are going to plan. In turn, these discussions and deliberations will also, lead you to kind of zero in on the room classification. For instance, there are certain procedures that you can do outside of a conventional operating room. I mean, this is defined in standards also. It is a surgical procedure, but you do not need to go to a conventional operating room. So that gets defined as a procedure room. Then you have the conventional operating room. And the third element that you see on the screen is a class 3 imaging room, which is also to say that you're looking at intraoperative surgeries. You are bringing in imaging into the operating rooms, and that's how it gets classified. Now, depending on what kind of work you're going to do and what kind of imaging equipment you're going to use, what kind of people you're going to use, you determine the size of the operating room. And then, of course, there is always a discussion around the room finishes and the room infrastructure in terms of MEP, because if you are going to do a ultra clean ventilated operating rooms, it is a fairly intricate air conditioning system, which we'll presently talk about in a few slides. When we get into this discussion, we also get into discussing culture. For instance, when we speak of change rooms, right? If you go to a Western country, you would probably have a male change room and a female change room. In India, we have a certain hierarchy of the human resources. So typically, a doctor would prefer to have their own set of changing rooms. Not very happy to change with the male nurses or the technicians. So that's something that we need to recognize and kind of provide for. Likewise, there are times when despite the hierarchy, it gets decided that a female doctor, a surgeon may change with the female nurses. So these are discussions that you have early on, because that will also have a bearing on the number of change rooms, the sizing of the change rooms, and all the support paraphernalia. Which brings us to the physical space. Now, where do you plan the surgery suite? The preferred location of a surgical suite is not one that does not call for any unrelated traffic through the department. So you place it wherever you want, right? If you have to plan a surgery suite, you can plan it wherever you want, except that you do not want any other traffic going through it. So it should be an end, unto itself, where even if you had to give a through traffic, it would only be for fire, exits and fire movement. In ordinary times, you cannot have anybody else walking through the department. That is one primary important criteria. One very convenient provision that you should be looking for is plan it under an interstitial floor. So in the section, while it may not be visible, you might see that red kind of oblong, shape, which shows that it is a service floor. Underneath, you have two floors. You can see that surgery 8 and cath lab DSOT 4. So these are two floors of surgery, on top of which you have a service floor, an interstitial floor or a skip floor, as we call it. It has two advantages to offer. One is that it can accommodate all the engineering for the operating rooms. Second, when you have plumbing downtakes from the floors above, they get diverted on this floor and therefore they do not need to run through aseptic areas. So this is one important consideration when we plan the physical space. There are certain critical adjacencies also. For instance, when we look at planning of the operating rooms, we need to understand, how far or how close are the intensive care units. For instance, if I'm doing CTVS surgery, it's very important that we should be able to move the patient quickly into the post-operative care, which is the CTVS ICU. The patient is heavily intubated, and surely you do not want to have the patient routed through all the public spaces. So if that is that's something available in the vicinity, you are able to manage the patient better. You are able to manage the sensitivities better. So as much as we have the choice of putting up the operating rooms wherever we want, there is a stipulation in National Building Code which says that you cannot take it above 30 meters. So this is something that we need to bear in mind, especially in metro cities where we tend to go vertical because real estate is very expensive. We do need to ensure that we plan in a manner that the critical care spaces are maintained below 30 meters insofar as possible. There are exceptions, but then there are exceptions. There have been times when I've been questioned, in a smaller format, on the upper floors, we may not be able to get the zoning or a chunk of space which allows us not to use any through traffic through the department. So in that case, it is also okay to use this in basement, provided the local bylaws allow, because from an engineering perspective, from the perspective of maintaining asepsis, we can still manage it. So the basements are not ruled out, provided the bylaws allow you to do that. Next, again, extending the concept of physical spaces is the size of the operating room. So oftentimes we are asked, what should be the size of the operating room? I think most of us would be familiar with the concept of the 20 feet by 20 feet, which is, propounded by NABH. So that's 400 square feet. So NABH is very happy allowing us this. What they do mention is that, this 20 feet by 20 feet has to be very clear of any kind of encumbrances. So, as Abhishek will tell us, later in the course of this conversation, from an architectural perspective, we try and plan it with a little more buffer so that, after accounting for all the paneling as is required for modular ORs, we should still be able to get this clear 20 feet by 20 feet. So if I am planning storage, if I am planning paneling, we need to bear in mind that we should be able to give the specialist agencies who can put up these, modular operating rooms clear space so that at the end of it, we're still able to get 20 feet by 20 feet. But having said that, veering away from that convention, I'll take you to the first square on the screen, which is an outpatient OR. So if you are doing, for instance, ophthal surgeries, right? You do not need, the conventional sedation and anesthetic equipment. So we should be able to do that in even 255 square feet. This is what is recommended as per HGI, Facility Guidelines Institute, which is a base reference standard for Joint Commission International accreditation. So this is something which is defined, and we could gainfully use the real estate to not make it too large when you don't need it to be large. The second one, again, which comes in under the domain of outpatient ORS with the need of anesthesia equipment, has to be pegged at 270 square feet. Conventional, as we discussed early on, it has to be 400 square feet. But if you are doing super specialty surgeries with a lot more equipment and people, then you can go up to 600 square feet. Case in examples being 𝐶𝐴PG or the cardiac surgery operating rooms. We're talking about orthopedic or talking about neuro. These are typically rooms that require a little larger setup. And if you feel that you are going to do intraoperative work where you're bringing in some imaging modality like an MR or a CT or an OM, then the requirements can even go up to something like 850 to 1,000 square feet. So this is a spectrum within which you work depending on the expectation and the utilization. This is the inside of a typical operating room. There are certain rectangles that some of them that
Hi,
can
excuse me. Your voice is not clear. It's kind of an echoing. We are not able to hear your voice properly.
Okay. Do we have Prasad who can help?
Sir, I can hear you. Mr. Abhilash Prabharan, maybe you can reconnect. You can log out and log in.
But 𝐾𝐫, your voice is clearer, better than Samir sir's actually.
Okay, let me try one thing. 1 second.
𝐾𝐫.
Yeah.
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 Yes, sir, we are on it. Just allow us a couple of minutes.
Thank you so much.
Abhilash, can you hear me any better now?
Yes, it's better.
Okay, all right. So I was speaking about the inside of an operating room. We did speak of 20 feet by 20 feet as the bare minimum for a regular operating room. But within the confines of it, you see this dark blue rectangle in the center, which is the OT table, which is typically 7 feet by 3 feet. Now, what you see around it, as a dashed light blue rectangle, you see 3 feet to the left, 3 feet to the right, and 3 feet to the bottom. So this is what we call the sterile field. We define this as a perimeter beyond which people will not move in and out, except for those who are allowed to do that, so that there is no break of scrub event. So this is very important because it defines the physical movement of the staff, but it also defines the air circulation and air distribution over the table. So the size of the plenum in international guidelines is determined by this aseptic field, sterile field. So this is something we'll speak about again, but I want you to bear in mind that that aseptic field that has been defined is practically in this instance that you see close to 10 feet by 9 feet or 10 feet by 10 feet for convenience of conversation. So this is a very important criteria that I would want everybody to bear in mind. Now, when we design, it's very important to take into account the user's perspective. In our case, the predominant user is going to be the surgeon. So what you see on the screen is what typically is the feedback we receive from the surgeons when we say that, what is your expectation? when we plan this. So the first thing that I speak about is that we want flexibility of use of the space. So we do know that an operating room is 20 feet by 20 feet. We have the table in the center, but what it also tells us is that around it we should have flexibility of movement and therefore lesser encumbrances on the floor, which is why we speak of providing pendants and all suspensions from the ceiling that you have, so that you have an uncluttered floor and flexibility of moving around the table. You can rotate the table as required. These are options that are available depending, of course, on what kind of surgery you're doing. The second important thing is that we want to maintain asepsis. Therefore, whatever you plan it in a way that we have ease of cleaning the operating room. Now that would be floors, walls, and any element, any contraption that you mount on the surface of the walls. So if you see the screen below, the picture below, you have a lot of storage that has come in, and if you notice, I, I if you can see my cursor, you have these voids above the storage which are inaccessible, right? So this is an example of how not to do an operating room, because you are creating surfaces that are not very amenable to cleaning. So this is one thing which surgeons predominantly tell us, that please give us a surface which is easy to maintain and we do not have an issue of infection in the operating room. The other element is ease of accessing surgeon's panel, theater lights, and pendants. So we have surgeon's panel from which you can control the operating light, you can control the peripheral lighting, and you can have all the alarms being displayed on it. So control of temperature, vision, visual control of humidity, all of it happening through a panel. That's important. Ease of communication and accessing patient data. Now this tells us, that if we have to facilitate ease of communication, we need to give a hands-free phone through which people can communicate. Today we have interactive screens available with audio communication. So if we are in a center which is going to take high-end surgery but doesn't have the necessary confidence or wherewithal, and they want to connect with a higher center, they are able to do with these interactive screens that you see on the in the picture there. In turn, if you are supporting a smaller center which is trying to do a surgery where they need support and guidance, again, it is through these communication systems that we should be able to assist them. The other element that we typically discuss with surgeons is the process of induction. So there is a school of thought which says that when we induce anesthesia, it should be on the table, in which case you do not need to make any additional provision. But if there is a school of surgeons school of thought which says that we would prefer to induct the patient outside, then we need to give a separate provision for it, which is an anesthesia bay where the patient is induced and then wheeled into the operating room. That's an important criteria, because if this is an element that comes in as an input later, then the planning goes for a toss and you have to start from the scratch. The other element we discuss is the storage provision. There are surgeons who feel that we do not want people to move in and out of the operating room very often. So then we want the storage to be provided from within. If that be the case, the sizing of the operating room also has to change to ensure that the residual space is still allowing us that span of 20 feet by 20 feet. So these are important discussions and inputs that we receive from surgeons before we start planning the surgery suite. Now, as much as we understand the user perspective as a planner, we also need to understand the patient journey. So what you see is a series of steps that a patient typically goes through. Very important for us to understand as a planner, because if we don't understand the process, we would not be able to plan appropriately for this. Likewise, as much as we have to understand the patient journey, so must we understand the staff journey. So this is another slide which shows us, how the staff comes in and moves out in and out of the operating room. So these processes also tell us what are the spaces required to make the surgery suite complete in itself, so that it lends itself very well to the processes that a surgeon typically goes through. Continuing the discussion around design principles, we did discuss earlier that we should locate it in a manner where there is no through traffic and affords seclusion. So that is a given. I mean, there's no compromising this. Now, very important when we plan is to get into this conversation around the zoning. So there are 3 designated zones. a lot of us are used to, this terminology of sterile, semi-sterile, and unsterile. Uh, the take is that, it can be either sterile or unsterile. We do not understand the terminology semi-sterile. So therefore, the right terminology to be used is unrestricted, semi-restricted, and restricted. Now, these are defined by the physical activities performed in each area, which I'll presently walk you through. But before I do that, I want you to dwell on these 2 points, which are a part of standards. Very important to understand because if we want to be compliant with international accreditation norms, this is something they typically ask for. I'm not saying this is set in stone. There are exceptions where we are able to kind of explain operationally how we are able to manage better. But if we have the choice of doing this, I think we are providing for a safer environment. So I'll read it out for you. An operating room suite designed with a clean core shall provide for no cross traffic of staff and supplies from the soiled, decontaminated areas to the sterile, clean areas, which means that you avoid crossing of clean and dirty. The second point that we have here is the shared use of a corridor for staff and patient access into the OR is acceptable, which means that when you get into an operating room, the staff moves the way the patient moves, but this same corridor shall not be used for delivery of sterile supplies into the OR, which means that all the sterile instrumentation that you're getting into the operating room has to follow a different pathway. So patient movement, staff movement, one set of corridor, sterile instrumentation movement, another set of corridor. This is something I want you to bear in mind as we go forward. A lot of people will have this question that, when you define this into 3 zones, what happens in which zone, right? So just to make it easier for the reader, we have the tabulation. In the unrestricted zone, we have the reception, waiting, the counseling room, staff lounges and lockers, control station where the patient is taken over from the ward staff by the surgical staff, and the pre-op and the post-op zone. These are areas where you may be allowed to move in your streetwear, right? The second zone that we speak about is a semi-restricted zone. Now, these are zones where you are expected to have changed. So you cannot be moving around in your streetwear. Now, these are typically areas like, clean and sterile supply rooms, sterile processing rooms, storage, instrument, scrub areas, and the corridor that leads to the operating room. These are all designated as semi-restricted area. You cannot be moving in your streetwear in these zones. And the last, of course, is the most sacrosanct area, which is the operating rooms and the clean core, where the clean instrumentation movement happens. These are spaces where you have to be gowned. You cannot be in streetwear. You're not just in your cleans, but you're also gowned. To help understand this zoning, we have taken the help of an illustration of an actual plan. So you see these 3 color codes. The one in pink that you see on the screen is entirely a restricted zone. What you see in blue are the semi-restricted zones, and what you see in the green are the unrestricted zones. To help you understand this better, I would want you to look at this zone. Is my cursor visible? Dräger, can you see my cursor?
Yes, sir,
Yes,
it is visible.
yes.
So this is the elevator lobby from which the patient is expected to be brought in. So these are areas which are in green, which are unrestricted areas. Now they are brought into this zone where the surgery staff takes over the patient, and this is the hold area, which of course is not seen because the furniture is not there. But this becomes a semi-restricted area. Beyond this, when the patient is taken into the operating room, this becomes a sterile zone or the restricted zone. Now, interestingly, if you see this, you have this corridor going all around these rooms. These are all operating rooms. You see the squares, 1, 2, 3, 4, 5, 6, and 7. These are operating rooms around which the patient is moving and then can be taken in and out, in and out. This is how the patient movement happens. The staff moves in through this change room. So you see this, these are change rooms. They enter from the unrestricted zone, change, and then get into semi-restricted zone, and thereafter into the sterile or the restricted zone. So this again is the way the staff will be moving around and into the operating room and out of the operating room. However, You see in the center another corridor, or what we call the sterile core, which is accessed through another entry lobby, which in turn is connected. If you see this, a little small elevator here, it's a dumbwaiter, which is a clean dumbwaiter, which is getting in turn connected to CSSD sterile store. So all the clean instrumentation comes up from this dumb elevator into this core, and then it's getting distributed into these operating rooms. So we are saying that the patient movement happens from this corridor, the staff movement happens through this corridor, the solid instrumentation will move out from this corridor, go into this blue corridor, into this soiled workroom and a dirty dumbwaiter. But the clean instrumentation is coming from this clean dumbwaiter into this restricted zone. This is the point I had been trying to make. At the end of this, if somebody still has a question, we'll be happy to revisit. This tries to explain through the color code of, this red is what the staff movement is like, something that I try to explain through the zones. Blue that you see is the movement of patient, and ultra clean core is again the movement of sterile instrumentation. The same drawing, but with depiction of the lines to show that there is no crisscross happening of green with red or blue. Coming back to design principles, and this is something that where we're stepping back a little to see what kind of column grid or spans work well. So while there have been instances where we work with 7.5 to 8 meters, we are increasingly moving towards adopting a grid of 8.5 to 9 meters, which works even better. What should be the floor to floor height? So if you are doing a retrofit or if you are planning afresh, you need to ensure that the floor height for the surgery suite is something that you take care of early on, because if you go with a conventional 10 feet, 12 feet kind of thing, you're likely to end up with a false ceiling, which is not very optimal. The requirement is that we should have a false ceiling at 10 feet levels, which is 3 meters. So in order to ensure that we achieve that false ceiling level, to ensure that the services run above the false ceiling are adequate and optimal, we should be looking at a floor to floor height of 13 feet to 14 feet. In which case you will get a decently respectable false ceiling height of 3 meters or 10 feet. The other important element that we need to work towards is the enclosure should be designed for radiation safety. So maybe Abhishek, if I can draw on you a little bit here, we typically go with a 9-inch brickwork to ensure that the ARB requirements are complied with. There is no emission of radiation from equipment like repeated use of C-arm or any imaging equipment that we use inside the operating room, especially if we are using it very prolifically. So, Abhishek, from your perspective, if we were to, request you that we give you a clean floor plate and you plan the modular operating rooms, how do we ensure radiation safety?
So generally what happens is we also have to see what kind of room it is. Obviously, if it is like say a CM or something where it is going to be a very temporary source of X-ray, sometimes we do require X-ray protection. In that case, what we do is we have either a 2 mm lead lining to the wall panels that we are using or to the walls. We install that. Even the doors have to be radiation proof, so even lead lining is done there. Normally to a height of say 7 meters, and especially in the area side of the corridor of, you cannot have a lead lining to the entire OR simply because it will become too expensive. So normally a lead lining is done to the area which is exposed to, say for example, a corridor which runs to the complex. So on that side of the wall we generally do a 2 mm lead lining, including if the door is also coming in that area, so we also do a lead lining over there.
To a height of 7 feet, did you say?
Yeah, around 7 feet to 8 feet. Yeah.
Okay. Thanks, Abhishek.
Yeah.
So beyond that, when we plan, we need to ensure that there are no wet lines running above the ceiling of the OR, which is why that interstitial floor or the skip floor that we looked at earlier is a very optimal solution because it allows you to divert all the plumbing pipes away from the surgical suite. So that's an important consideration because you surely don't want any dripping and inside the operating room, especially from soil lines and waste lines, because you want to maintain asepsis, and infection control is of paramount importance. Likewise, when we do need to take openings in the slab for running the duct work and all of it, but any opening in the slab for running of services has to be neatly and effectively sealed. So very often we have seen instances where services slab cutouts are done, but if they are not sealed and closed very properly, they become a source from where rodent movement and other infestation can move in. So there'll be a time before you see it below the false ceiling because you have a very neat false ceiling in the operating room, but things start accumulating atop the false ceiling, which of course is not acceptable. So this is something that we need to bear in mind when we're planning and also when we're executing. So this is something that we should be acutely aware of. Finally, adopt finishes that afford a seamless finish. Now, this is something that is, of course, Abhishek's domain also, and he will hold forth on this in the subsequent slides. And we should be using material that inhibits growth of pathogens. So again, this is something I'll dwell on Abhishek to help us navigate that challenge. So these are things, like I said, at the start, what you see when you walk into operating room is what you see, but what happens behind the scene is what is of interest to us today. So this is a primer on what is the engineering provision that you'll typically see in an operating room. We of course need power, and it is important that we have uninterrupted power. So we need UPS, which goes without saying, but we also need power which will not fail. So in case there is a fault, the typical safety mechanism is that it should trip. But if it trips and you are already working on a patient, that's not going to work. So how do we ensure that we have safe power and uninterrupted power both at the same time without compromising safety? So that's something we'll come back to. Lighting that we speak of as a provision is something that we plan for at 1000 lux. Now, some of you might have a question as to, 1000 is a fairly intense, very bright light. So why do we need 1000? So if you notice, subsequently we've written it has to be dimmable. The reason why you need 1000 is that when the surgeon's working under the operating light, we're talking about illumination that can go up to 160,000 lux per dome. So when you're working under very bright lights, you need to step out and look outwards, you would feel blinded, which is why the peripheral lighting in the operating room has to be, scalable up to 1000. Normally, you would maintain it at maybe 200, 250 as is convenient, but should the surgeon need to, you should be able to scale it up to 1000. This is the requirement as per standards. HVAC of paramount importance because air quality is uncompromisable, non-negotiable. So it has to be designed to maintain air quality as per recommended standards. Again, something that we'll come back to. Insofar as plumbing is concerned, there is no plumbing inside the operating room, but of course you need water for scrub, which has to be good quality water. Medical gases, of course, important, something we'll dwell on. So this is a primer. So these are elements of engineering that will go into the making of an operating room. The next one is fire safety. So, in case you have a fire inside the operating room, and believe you me, this happens more often than you would hear about because nobody wants to talk about it, but these are instances that do happen. So if it does happen, how do you take care of the patient? How do you take care of the infrastructure? How do you take care of the staff? I mean, I'm sure you all realize that, on a patient which is cut open, I cannot possibly use a fire extinguisher. So how do you manage these challenges? Something that we'll talk about. We need voice connectivity so that the surgeon, in case the surgeon wants to connect with a peer or somebody outside, they should be able to communicate without having to physically handle a phone. So it has to be independent, hands-free. You need data connectivity. I mean, this is ubiquitous now. No gain saying that you need a lot of data that can be archived, brought into the theater. And Abhishek, of course, has been doing integrated operating rooms, so I'll request him to share his experience in doing this a little better. We need audiovisual connectivity because if you are a teaching institution and you want to communicate, the kind of work you're doing for the benefit of students outside, we need this provision. And the last is BMS, which is Building Management System. Very important because we all know healthcare buildings are energy guzzlers. Within that, an operating room guzzles even more energy. So it's very important that expensive infrastructure like operating rooms, which takes up a lot of power, both in terms of air conditioning and in terms of application of medical equipment, is designed in a way where we are able to conserve power as well, which is possible only through building management systems, something that we'll speak about in the forthcoming slides. So we spoke about electricity. We said that, we need power. We need continued power, but we also need safe power. So I'm sure all of you know that in your homes also you'd have seen you have this breaker. There will be instances where, there is an overheating of an equipment, like a geyser or a refrigerator. In the earlier times, that was not very uncommon. The power trips. So wherever there's a fault, the power tend to trip because it's a safety mechanism. Something we cannot afford to have in an operating room, which is why we have a contraption called medical grade isolation panel. This is something that allows the earthing to be non-grounded. It's only when the fault occurs that it will get converted to conventional grounding. And thereafter, if there is a second fault, of course, it's going to trip. But you have sufficient window period available within which to identify the fault, rectify, so that you can continue working on the patient without a compromise up to a point in time. So this is something which is not very expensive. Maybe for a 10 kilowatt kind of panel, it could cost you something like 7 to 8 lakhs. Small price to pay for safety, that is of paramount importance, something that, in case your consultant is not aware of, you as an administrator, you as a planner, should be insisting on, should be requesting for. The other important element in terms of provisioning of electricity is the number of power receptacles. So this is also up for debate. Conventionally, we would have seen in Indian operating rooms, you would have had maybe, 12 to 18 power receptacles terminated either on the walls or on the pendants or in a combination of both, some on walls, some on pendants. So the standards say that, on each wall, you shall have not less than 2 power receptacles. So we have 4 walls. Therefore, these 8 that you see at the right are power receptacles that go on the walls. And the 16 and 12 that you see are largely determined by, the requirement of the anesthetist. The most intense requirement is for the anesthetist, which is 16 and 12 for the surgeon's pendant. This, of course, is variable, which we'll see again in a subsequent slide. HVAC, like I said, asepsis of paramount importance. So if you look at the standards, it says that, we should design for 18. But then a lot of these prescriptions of temperature are also determined by the standards set in Northern America, northern latitude. So for them, it's more about heating than cooling. We also have this school of orthopedic surgeons who are used to working with bone cements, for joint replacements, where they feel that, if it is a little warmer, the bone cement will set faster. Therefore, I need temperature going down to 16. So I want the audience to know that Merck has come up with bone cements which take just as long to set even at higher temperatures. So it is no longer a very important criteria. In fact, today I was reading in the newspapers that joint replacement is now going to happen without cements. So I think this very big challenge that we as engineers and planners face, that, we need to plan for 16-degree, which is both capex intensive and opex intensive, is no longer going to be a criteria in the times to come. But one important element that I wanted to share is that, we might be located in an area where the temperatures go sub-zero or zero, So in that case, we need to provide for heating, not so much for cooling. Something that we need to bear in mind when we are planning the HVAC. It's not always about cooling. Depending on the ambient conditions, you might be looking at the necessity and the need for heating as well. So air conditioning is about both heating and cooling. Design RH that we need to maintain. RH is relative humidity, should be between 50 to 60%. Anything below 50 would also mean that, the users are a little comfortable. There could be generation of static electricity. And then anything above 60 would mean that, you are likely to see a lot of condensation on the walls. So this is a very optimal range that you want to maintain, 50 to 60, to maintain optimal conditions inside the operating room. The other important element is that we need to maintain positive pressure inside the operating room, which is done very simply by pumping in more air than you take out of the system. So differential positive pressure is something that you need to plan for. Now, when you plan for it, your air conditioning system will ensure it, but you also need to ensure that the system allows you to monitor it on an ongoing basis. So, which is why you have something called pressure differential manometer. So, you have that contraption mounted outside the operating room, which will tell you that your room is actually being maintained at positive pressure, or it has kind of been compromised and the pressure is falling and it's become neutral or negative. So that monitoring is as important as planning and executing for positive pressure. Cleanliness, of course, you have to maintain. So, there is a school of thought which has been speaking about cleanliness in terms of class 10, class 100, class 1000. Not a terminology that we in healthcare for operating rooms use, very often. It's something that is more commonly used in pharma. For us, it is important to ensure that we have a particle count that does not exceed 100. So practically, we are talking about class 100 conditions under plenum. Uh, so very important to ensure that we have filter integrity met. I'll show you a picture. Maybe that will help us understand better. So you see this. This picture at the center, which is a plenum. We use this for the laminar flow, and you have what you see illuminated on the top ceiling surface are a set of filters. And you see that blue line at the bottom, the dark blue, relatively dark blue rectangle at the bottom. So I take you back to the original discussion where we had spoken about the field of asepsis. Now this is important because this is determining, what staff can come closer to the table and what staff has to stay outside because they are not gowned and they are not going to create a break of scrub event. What you see in the bottom as a darker blue is also a reflection of the size of the plenum. If you go by international guidelines, then the size of the plenum should be 10 feet by 9 feet minimum, or 10 feet by 10 feet as you would have. However, if you go by the Indian guidelines, it also allows you to limit it to 6 feet by 8 feet, which is what NABH allows us to do. The important thing to remember here is that when we have this diffusion of air from the plenum, you do it at a velocity which is straight, which is why it is called laminar airflow. The reason why we do it is to entrain any particulate matter out of the surgical site. So you have particles in air which are not visible to the eye because they're very small. But with this kind of filtration system, with this kind of filters, which is HEPA filters, with this kind of velocity of air, the idea is that you push those particle matters down and away from the surgical site, right? This is how you maintain aseptic conditions in the place where you're cutting open the patient for deep wound surgeries. So I take you back again, if you've got this clear. For each operating room, we need a dedicated air handling unit. So an air handling unit is a machine which which pumps cool air into the operating room, cool and filtered air into the operating room. It has to be dedicated in the sense that you cannot have two operating rooms being serviced by one AHU. And as to where is the location to be, it should be placed in a way that can be accessed and maintained without having to get into the restricted zone. That is an important consideration. We often have surgeons coming and telling us that we need 100% fresh air because we need the best of the environment. So I want the audience to know that with the kind of filtration that is instituted, which is HEPA filters, which is 0.3 microns porosity, you have the best which is possible. And with the kind of IAQ that we see around us today, which is, I don't think I need to get talking about the IAQ. Who is to say that pumping in 100% fresh air is any better than recirculated air within the operating room, of course with a certain degree of dilution, but through filters, which is getting progressively cleaner. So our submission is that this concept of 100% fresh air is no longer valid unless you are doing a very clear septic surgery. In that case, for the purpose of dilution, you may do that. But otherwise, all ultra clean surgeries, be that cardiac, be that neuro, be that joint replacements, you should be able to do it with 20% recirculation, 80% recirculation, 20% fresh air, which is enough to dilute the buildup of any gases in the environment. So the point being made is that we do not need 100% fresh air. We are okay to recirculate 80% fresh air because then we are able to maintain the criteria of contaminants in the environment as per standards. But if you have to do 100% fresh air for whatever reason, then please ensure that you also have a heat recovery wheel, because it is extremely expensive to work with a 100% fresh air system in an operating room. The reason is that you're working with air changes which go up to 20. So when you have 20 air changes per hour and you have fresh air coming in all the time, the cooling load is going to increase substantially, in which case you make use of the enthalpy wheel to reduce the cooling loads and thereby conserve energy. Another important element that we speak about is setback mode. So this is an arrangement where because we are going to maintain the data at positive pressure. What we do after the surgery in typical operating rooms is that you switch off the system, you switch off the AC, you switch off the lights and all of it. But then you are compromising on the pressure differential that you are supposed to maintain 24/7. So when you institute a setback mode, what you are doing is you are reducing the airflow into the operating room, but thereby also ensuring that with the connectivity of BMS, building management system, ensuring that in the adjacent areas you are progressively reducing the airflows, so you still able to maintain positive pressure relative to the corridor outside. So we spoke of those three zones, right? Restricted zone, semi-restricted zone, unrestricted zone. Across the spectrum of the three zones, you'll start reducing the airflows. So you are still relatively maintaining positive pressure in operating room despite reducing the airflow. That's a point that is getting served by the setback mode. These are plumbing provisions. You see the provision of scrub sinks. You have stainless steel available. You have solid surface available. Yeah, this is another element that I wanted to speak about, fire safety. So we are conventionally used to having hydrants. I'm sure all of us have seen this in our residential buildings as well. In a hospital, you will have seen sprinkler system through which get activated at a certain temperature so that water gets sprinkled and the fire will get quelled. We use extinguishers, but of course we cannot use them on the cut open patient. Detectors will tell you that there is smoke and therefore there must be fire, but it doesn't help you quell a fire. So how do you manage fire? We have something called a gas-based suppression system, which is an inert gas, which is not too heavy because it should not asphyxiate the patient, but will be heavy enough to quell the fire. So that's something that you need to insist upon in areas where you cannot use conventional sprinklers. It's similar to what you use, the network of piping is similar to what you use for sprinklers, but instead of water, you have a certain proprietary gas which will quell the fire. Yeah, without exposing the patient to any kind of particulate matter. These are operating lights and peripheral lighting. So peripheral lighting, Abhishek, can I invite you to advise us what kind of peripheral lighting is typically required in operating room? What do you as a specialist in modular operating room provide? Is it a special light or is it a conventional light fixture that we can put in?
Generally, yeah. So mostly the peripheral lights, I think you already clarified in few slides back. So the lux intensity should be between 1000 to 500 lux. It should be a non-reflective light, flicker-free light, so that it should not interfere with any video cameras or anything which we are using in the operation theater. So and the intensity should be between 1000 to 500 lux. Preferably the color temperature should be such that it should generate a white light, so something between a 5000 Kelvin to a 6000 Kelvin, and this peripheral light should be waterproof. So we generally recommend like IP54 or anything above IP50. So 54 or a 65 should be sufficient, so that if there is any problem due to water or any leakage, so it should not enter into the light enclosure.
So are these easily available, Abhishek, the lights, or do you have to procure them specially?
Sorry, I didn't get you.
Are the lights easily available or do you have to specially procure?
Yeah, they are very much easily available. There are brands like Philips, there are Wipro. We make an in-house. We have the OTs that we provide. We have an in-house brand. So there are a lot of lights which are specifically for medical purpose. Companies make it, which are specifically for healthcare requirements.
Also, Abhishek, our surgeons often tell us that, after we finish the surgery, I want the UV light to be switched on because it will disinfect the operating room.
Yeah.
In your practice as an international provider of modular operating rooms, is this something you recommend?
It's not, I would say not recommended, but we in our journey of this modular OT, we have also faced a few instances in very big hospitals, would not like to name them, but they also want UV lighting in that. But if you see all the modern operation theaters, we generally keep provision into the wall panels that there is no bacterial growth, and even if there is any bacteria, there is provision that these bacteria gets killed. So even if you don't provide the UV light, it is not going to make any major difference. Obviously, if certain requirements are there where they UV light to be present, having them is also not going to affect the OT. So even if it is there, not there, it's okay.
Okay, so you're saying surface disinfection is something that you ensure by way of choosing the right material, so
Yes.
you're not too worried about it, is what I hear.
Yes. Yes.
Understood. The last element that we wanted to touch upon is the provision of medical gases inside the operating rooms. What you see on the screen is an extract from HTM, which is Health Technical Memorandum, a set of standards specific to provision of medical gases in a hospital environment. If you notice, the provision is typically a little more than what you conventionally see in an Indian operating room. Again, a matter of deliberation with the surgeons, so we cater to their expectation and requirement. But if it is standards you have to follow, then this is the provision they speak of. O2, of course, stands for oxygen. N2 is nitrous oxide. MA4 is medical air, which is compressed air being delivered at 4 bar pressure for breathing purposes. SS7 is surgical air, which is used for instrumentation like orthopedic drill, orthopedic saw, tourniquet. That's where it is in use. Therefore, you would see in the operating room for the orthopedic surgeon, there is provision for as many as 4 outlets of surgical air 7, which from an Indian perspective, many of us might think is an overkill. We have provision for vacuum. AGSS is again, Abhishek is a specialist not only in modular operating rooms but also medical gases. So Abhishek, can you advise us what is the importance of AGSS in an operating room?
So AGSS, nowadays there is a concept which is getting famous, which is called as green anesthesia. So they don't want in the anesthesia room or the operating room any harmful gases to the present, because the people who work in the OT, they work there for almost like 10 to 12 hours of their life of a day, and in that case, breathing these gases can have a long-term effect on their body and on their health. So to prevent that, these gases have to be removed, and this is where the anesthesia gas scavenging system works in a very efficient way. So every pendant should have a AGSS outlet. What it does is basically any unwanted gases which are coming out of your anesthesia machine, because anesthesia machine itself is a major source of these unwanted gases. So your pendant should have a AGSS system which will take out these unwanted gases and either send it to your AHU for recirculation, or it can be even send it to the atmosphere where it can go into the open air. So AGSS finds a very important place in the operating room for removing these unwanted gases.
So it makes it a safe space for the staff.
Absolutely. But I mean, long-term period, even I have taken certain feedbacks from the staff that by the end of the day, when they go home, they still feel that nauseatic feeling because of working in the OT. So if you have an AGSS system installed, I think these health effects would not occur.
Abhishek, entirely your domain. I want you to help us understand, what are our choices in terms of interiors and finishes, because we address it from an engineering and a space planning perspective, but this is a place where surgeons spend long hours, so it has to be conforming to standards, but it also has to look good and it has to be functional. Please tell us, how do you help us achieve this?
We have whenever a customer calls us for an operating theater design or operating theater consultancy, so the main thing that which we talk about it, what is the material that they are going to be using for the walls and the ceilings, or even for that matter into the corridors.
Sorry, Abhishek, we will take it one by one. So What kind of doors? Because this is a slide on doors. If you can advise us on that, then we'll move to the walls and the ceiling and all of it.
Yeah, so doors in fact can be, we generally have a stainless steel doors,
Okay.
which can be powder coated, or we can have a design which you are seeing in the picture, something like that.
Okay.
It should have a glass window, say typically of a 400 by 400 square or a circle. So there should be a visibility to the corridor, and from the corridor to inside of the OT for safety purposes. The doors can also be made up of a galvanized steel with a powder coating of an antibacterial variety, which will not cause any infection. So
Okay.
typically the doors can be majorly of two types, SS or a GI with a powder coated of antibacterial protection. In case of wall, I would recommend, we generally recommend either a SS304 grade material, which can be powder coated with antibacterial coating. Generally, these antibacterial powder coating should have silver ions. So these silver ions are typically necessary to kill the bacteria if there is any bacterial growth which occurs, or if there is any infected patient which is being treated or operated inside the OT. So
Abhishek,
second,
what is the longevity of this silver ions that are embedded in the wall surface?
it is for the entire life of the operation theater. So
Oh,
this yeah, so they typically we say around 12 to 15 years is what the longevity is. But if the 15-year lifetime, it can go also beyond that. It also depends on how you maintain your operation theater. So
understood.
stainless steel is one option. Then we have the galvanized iron, but galvanized iron itself is a material which can be rusted. So we recommend to have a good powder coating, say of at least 60 thickness, which will with antibacterial protection and silver ions, which will give you a good protection against any bacterial infection. And the very good material, as it's pointed out here, is glass. Glass is also excellent material for having a walls, simply because it will give you a good outlook. It has got various graphical capabilities, so you also have a motivating atmosphere inside the operation theaters. You can have good pictures so that the people who work inside the OT feel nice when they are working, instead of just being in a claustrophobic atmosphere. So these would be our recommendation. Flooring,
Abhishek,
we can,
anything on the flooring?
yeah, so flooring is typically and 95% of the time a vinyl flooring. In the area which you said about the sterile zone inside the OT, we generally recommend conductive flooring, which will have carbon content in it. So if there is any chances of any static electricity which comes out of the equipments which are being used, they get discharged through the grounding that is done inside the OT. And in other areas, apart from the sterile areas, we can have a non-conductive vinyl flooring, including the corridors and scrub rooms.
Okay. Ceiling, what do you recommend?
Ceiling, again, it can be, generally we prefer GI because the capex requirement of the OT should also be balanced type. So we recommend a galvanized iron ceiling with a powder coated antibacterial. There is another option, like if you want the entire OT to be of a stainless steel, especially in areas where there is more coastal, like on a seaside or something, where there are chances that the sea air can cause damage to your operation theater. In that case, we recommend even the ceiling should be of stainless steel with a powder coated variety. Then again, the ceiling is of two types. You can have walkable ceiling, where for maintenance purpose, a person can go above the ceiling, walk on it, do the maintenance if any required during the over the period of time. Or you can have square ceilings, which we generally called as the clippable ceiling. So these generally have 600 by 600 tiles, which can be individually removed, so that even in that case, the maintenance can be done just by removing the tiles, going above the ceiling and doing the maintenance work. Both the options are equally good. It depends upon what is the size of the OT.
Right. So, Abhishek, would you ever provide a window in an operating room? We have people who ask us whether we can do that.
Yeah, so a very good question. We have had questions in past where they ask for windows simply because they want natural light to come inside the OT, and it is very well we can provide that. But in that case, what we do is we provide either blinds inside those windows. So in case there is too much of light, those windows can be blocked. It can be either manual blinds, or there is a new technology which has come up, which is called as the electric glass. So in electric glass, whenever you place the button, it becomes transparent, and when you switch it off, it becomes opaque. So this type of arrangement can help you block the natural light if it is becoming too harsh. And in case the light inside the OT is or the customer or your doctors or the surgeon wants some natural light to come in, we can make the light transparent for the natural light to come in. But
That's awesome.
it is absolutely okay to have windows inside the OT.
Okay. So this has been the journey, audience. You see the picture on the top left, which was an operating room of the yard. From then to now, it has evolved to have a lot of gadgetry, lot of screens for integrating, to archive patient data in terms of radiology images, lab data, patient data, interactive screens. You can feed from here. You can use analytics, to understand, how the patient's going to unfold. So it's been a journey over the years, and I'm sure your questions, happy to take them. I'm sorry we overshot the time, but we just couldn't stop sharing. There was so much to share. So